Should be no problem, right? State 5 design consideration of electrical transmission line. So it's basically in your notes, the electrical consideration, mechanical, economic, what else? Environmental. What is the one more? Can't remember. Anyone? What is the one more? Chapter 5, I think.
Hi everyone. Today we are.
Sorry, open the wrong one. I want to open the PDF. Question 1 will be about these electrical factors, mechanical factors, environmental factors, economic factors. Oh, so should be 4 only, not 5. Consideration. Electrical factors, mechanical factors, environmental factors, and economic factors. Should be 4 design consideration. Are you okay? Then question 2. Can you get the answer? We only have 4 questions. Hello? I got the wrong answer. Okay, we can look at it. Others? Other than Nicholas, why I feel like you all are not that actively participate in the class compared to circuit analysis time. No, last time circuit analysis also online class, right? You are okay, I can ask a lot of questions. I know already. Because power system is too easy, so no question. Wrong answer. Which one wrong answer? Sometimes it's not because of wrong answer, it's because my answer it run off too early. Cannot get the angle. Okay, cannot get the angle. Then we look at it. We only have 4 more chapters. Okay, where's my answer? Okay, so first of all, question 2. You see, right? Question 2, they ask for the ABCD parameters. So you know that this is a 200 km, right? So it's a medium line. So medium line has its own medium line equations, right? So, 1 minute. My writing. Okay. Oh, I cannot see my mouse movement. Okay. Where are we? So A equals to D equals to 1 plus YZ over 2. So this is the equations, confirm fixed already equation. So you just need to use this equation for medium 200 km medium line. So you have short, medium, and long line. Okay. So both of these three length, you have different formula. So what is a y and z? So y will be this y, but then this one is per km. Now they tell you is 200 km, so you need to use this y. You need to use this value times 200. Then z, you need to use this value times with 200. Okay. Then substitute inside here. So basically, you will get this answer. Okay. Then equation for C equals to y multiplied by 1 plus yz over 4. So again, the y you need to use the y and z is after you multiply with 200, yeah. So you all can say cannot get the angle, is it because you didn't multiply with the 200? If you straight away use the values here, then it's actually wrong. Okay, you need to multiply with 200 first. Okay, then C you should get this one. Then D you have already here, A equals to D. C you have already. Then B is equals to Z is equals to 97.32 angle 80.54 degree. So why Nicholas and Edin? Can you get the correction for this? Part A, you're right. Okay. Then part B, the sending end voltage and current. So part B also formula. There's a formula, right? EPS equals to AVR plus VIR. Then IS equals to CVR plus DIR. So you already have the A, B, C, and D values, right? A, B, C, D here are okay already, right? Then what you need to find out is VR and IR. So if you have VR and IR, substitute here, then you can get VS and IS. Okay. So what is your VR? I think I know what happened already. You all use line to. It's about the line to line or line to neutral, maybe. VR itself is actually equals to 220 angle 0 degree divided by 3. So basically you get 127 angle 0 degree kilowatt for line to neutral. Okay, then IR itself equals to 250 angle negative shift cos 0.99 divided by 3 220 0.99. Then you get VR 0.6627 angle negative 8.11 degree M. Then you get this VR and IR. Once you get VR and IR, substitute in here, time multiply with the ABCD that you get from part A, then you get VS and IS. Any problem here? Yeah, why is it negative? Negative shift cause. Why is it negative? Because of the conjugate. Yeah, because of the conjugate. And you need to divide by 0.99. Why you need to divide by 0.9? Supposedly, normally we do. Normally our formula is like I equals to S over sub 3V, right? Then now S here over sub 3V and then power factor 0.99. Why you need to divide by power factor? It is because the the value given is megawatt W. So this is P, not S. You get what I mean? So you want to get, change P to S, then you need to do like this. S divided by power factor in order to convert P to S. Do you get what I mean? When do we use square root 3? Divided by square root 3, right? It is because of this question really. We already had that. Why is it? There's a reason. Because from the P formula is actually P equals to sub 3 V line to line I line, then multiply with power factor. And then the S equals to 3 VI conjugate is actually for three phase, then you use yeah. For three phase, then you use 3 VI conjugate. Then single phase you will use VI conjugate. Yeah, I think so. Can you get what I mean? And the third tree is basically to to convert the line to just I think it's line to line to neutral already. Line to neutral. Oh no. This one is above here. Okay, the third tree here is because of this formula. P equals to third 3 V line to line I line. Okay, Nicholas? Okay, if okay, then we proceed to part C. Percent regulations, actually also nothing lah, but you not really important lah. You don't want to do is okay. We just skip part C, I think. Okay, then can you try the question 3, part A and B? I give you 5 minutes to look at it, okay? Sorry, there's a bit other coordination work for the capstone thing. That's why my phone keep message coming in. Okay. Where are we? So question 2. Now they want in per unit ABCD parameter. So can you do it? They give you 100 MVA, right, and 230. Okay. So it means what it means. It means here you can have the y and z in per unit form. So you want to have y z in per unit form, then you need to use z. You need to find out z base. So z base will be equals to v squared over s. The base value, the base value. So means equals to this one 230 and 100 m over 100 m. Okay. So z base you are going to get 529 ohm. 529. Then y base, okay, y will be equals to 1 over z, right? So it will be 1 over 529. So you get 1.89 times 10 to the power negative 3 Siemens. Okay, so once you have y base and z base, so just now the actual y and z value you want to have per unit, then you need to divide it by the y base divided by z base, right? So y, do you get what I mean? Y pu will be y divided by y base. Z pu will be equals to z divided by z base. Then the formula is still the same, just that now you substitute the new z y value in, so you get the different a b c d. But then actually the a and d you no need to do because it is already in per unit. Because y is 1 over ohm, z is actually ohms, the unit. So ohms and 1 over ohm means no unit already. So no unit means it is per unit. So this is already in per unit. But of course, you want to do also no harm. You are going to get the same answer. That's why I say equals to Q1. It means equals to the answer in Q1. So B, C, D value you should be able to get. Then part B, the sending end and the part B, sending end and the what's that? Sending end current and voltage you need to get. So then you need to get I base. So I base will be equals to S base over cert 3 V base line to line. So you are going to get 100 divided by cert 3, 230. So you are going to get 0.251 kilo amp. Okay, so V line, V receiving end VR in PU will be equal to, original is 220, right now is 230. So it is 0.9565 angle 0 degree. And then IR PU, you have IR PU. Yeah, this IR value, right? Then divided by the base, that IR value 0.6627 angle negative 8.11 divided by 0.251 is 0.251, the base value. Then you will get 2.64 angle 8.11 degree. Are you okay? Then if you have IR and VR, then everything you can substitute back into just now the equation AVR, PIR, CVR, and DIR, okay, with the ABCD values in per unit as well. Then you are going to get VS and IS in per unit. Can you get it? Okay, so actually the VR, right, you actually that they didn't really state that what you need to use this VR. You can use line to line or line to neutral. Actually, it's not a problem. Question 2 part B. Question 2 part B. You can't get the answer? Which answer? VR and IR, can you get it? VS and IS. VR and IR, can you get this? You are you substituting the I think what I know already what because at the end, yeah, it's actually the line to line and line to neutral problem. At the end, I think you should get. I think your answer is 155.4. Is it VS? If your VS is 155.4, and actually that is correctly, then multiply this VR value, part B, why you get 269.2 is because the 155.4, okay, they multiply with sub 3 in order to change to back to V line to line. This is V line to neutral. Nicholas, can you get it? It is a line to line and line to neutral problem only. Actually, both the answer is okay. Can I answer again? What is the thing that you can't understand? This formula they use inside the formula, the VR here, they change divided by certain to change it to line to neutral. So they substitute line to neutral in the equation. Can you understand? So the VS you get is 155.43, right? It's actually line to neutral. Then they multiply with sub 3 to get line to line. Understand? So it's actually the problem of line to neutral and line to line only. Angle is not important. Angle is not important. But of course, if you want to put in angle, it's okay also. Angle actually should put lah, but then they just take the magnitude and then multiply by 3. Okay? You're totally different. How come totally different? No problem lah, as long as you have the correct calculation. Actually, my answer also got a lot of problem. Perhaps it's a mistake here from my answer. Okay? As long as whatever value, this is just a calculation. So as formula, you substitute CD, VIR in, then whatever that you get, then should be the answer. Okay? So I just want you to know that how to solve for the problem for the medium and short line. Okay? Yeah. So the slide maybe calculation, the calculation, as long as substitute in, then you press calculator, whatever value that you get, that's the answer, unless you press it wrongly. Okay? Then question 3 should be okay. So the line to line and line to neutral is a problem, but because actually they didn't say one line to line or line to neutral. Inside these equations, you want to use line to line or line to neutral, actually also okay. Sometimes they use line to neutral, sometimes they use line to line. Okay. But of course, if this question is not in the exam, then I will state it clearly. Okay. But not worry. Okay? When I say no worry, then it means you should know what I want to tell you, right? Okay. So if you're okay, can you try to do question 4? Okay, can you try to do question 4? Question 4, any problem? So question 4 should be quite easy, because 40 km, 40 km it means what? Short line, right? Then they give you resistance per km, L per km, so you need to multiply with 40 km. Okay, then there it's so nice that they tell you short line already. Sending end voltage, voltage regulation, sending end power, transmission line. So when the load is this one, lagging, and then it is leading. Can you do it? Hello, can you do it? Why I seriously suspect that only a few questions do the question. Can you please tell me I'm wrong? Okay, so first of all, you need to get the impedance value. So Z will be equals to what? R plus J omega L multiplied with the length. So basically you get 6 plus 20, 6 plus 20 J ohm. Okay. Then the receiving end voltage VR will be equals to 220 over 3. So they get 127 angle 0 degree V line to neutral. Yeah. Then complex power at the load side, receiving end SR equals to 281. Even the load value here 281 mega VA. So means is S angle shift cos 0.8, right? So basically you get 204.8 plus J 228.6. Okay, so this will be your real power P and this will be your Q. Then current I R will be equals to 381 angle negative here because of the conjugate 0.7 degree, okay, over 3 times 127 angle 0 degree. So it's equals to 1000 angle negative 36.7 degree. Yeah. Are you okay? So this one is S divided by 3 VR. So this one they use S equals to 3 VI conjugate. Okay. Then Vs will be equals to, the formula will be Vs equals to VR plus ZIR. And this is a formula for short line. So substitute everything in, then you get 144.33 angle 4.93 degree kilowatt. Are you okay? Then the sending end power will be VSIS, sending end current multiplied by with the sending end voltage, three phase conjugate. So you substitute in, then you get 322.8 plus J 288.6. Okay. Voltage regulation no need to do efficiency. Efficiency equals to P receiving end divided by P sending end. So which is 304.8 divided by 322.8. So you get 0.944. 322.8 here, 308 is here. Yeah, 304.8. Any question? You find Z because ABCD for, if you refer back to the notes, for short line, can you see? The ABCD you need, but then for short line, short line A equals to D equals to 1, B equals to Z, C equals to 0. So basically you find Z, then substitute the ABCD in, then this is a formula for short line. So you only need to find VS. IS is basically equal to IR. Nicholas, can you understand what I mean? The question. This is just an equation given in the lecture notes. Any other question? Are you okay? Brian and Edin say okay. Colin say no questions. Okay. Then if part B, leading power factor. Okay, leading power factor basically the answer is the same lah. Just that some symbol change only. I think Z value I think is still the same. Yeah. VR value should be still the same. Here is the thing that you need to change. Suppose original will be negative already. Right, negative here, right? Then here it is. I think it's not negative here. So this one you need to 322.8. This one you need to calculate it out over it. Okay. Then for IR here, I current receiving current. So this one conjugate also become positive, right? So here it becomes positive. Okay, then substitute the value in. So you get instead of this value, because of the IR change, sign change, you get 1, 2, 1, 2, where is it? 1, 2, yes, yeah, 121.39 angle 9.29 degree. Yeah. Then SS here, because of this negative IS, so you have different value. 322.8 is the same because P is not affected. Then minus J 168.6. Are you okay? Then basically this one is still the same because P value not really changed. They change only the Q value. Okay. So this is the difference between leading and lagging. Okay, lagging and leading. So it's basically only the current here because of the negative for power, the complex power. Then here become positive. Okay or not? If you are okay, means we officially settle our tutorial 5. Okay. Answer for question. Which question? Class dismiss. Not yet dismiss lah, Kok-Wing. We still have, I said 3 to 5:30 leh. Then I only teach you for 47 minutes or then later you all will complain. Say I'm not doing my work well, right? 4A 4A answer. 4A answer and 4B answer is the same. It's 4A answer. 4A answer in red and 4B answer in YR divided by 127. IR 127 and not 220. It is because they use these equations they use line to neutral. Yeah, I believe if you use a line 220, then you no need to times with 3. I think it will be cert 3. Yeah, there is a formula. Did I send to you before? There is a formula about the power, about the, I mean the use line to line or line to neutral power, then you are going to have 3 or cert 3. There is a formula design. Where I show? I think I posted somewhere in. This is chapter 5, right? Lecture 5. Extra material gone. Recorded video gone. No. Extra teaching. Chapter 3. Chapter 2. There is a. There is actually a place that I post equation for. Is it the extra notes? Here I write line to neutral. You use 3. Then suppose line to line you use cert 3, if I'm not mistaken. Nicholas, do you know what I mean? You want to use 127 or 220 also can, but then I can't remember it. This one of it is 3, another one is cert 3. Nicholas, do you get what I mean? But yeah, never mind. Later on, I will search the formula list and then I post to Google Classroom. So if 220, then supposingly it's 3, yeah, if you use 220. But no, sorry, yeah, I can't remember the formula. Okay, yeah, most of you know, right? I have a very short memory. Yeah, because I'm not the one who needs to sit for the exam, so I really forgot all the formula. Okay, but I will later on I will post a formula list to your Google Classroom. Okay, about this, there is actually there are 3 formula that then the different thing. If you use a different line to neutral or line to line, then you have different thing. IR 800. How can you get 800? For part, it's impossible 800. It's not really possible to have 800. If you have 800, is it because you didn't divide by this 3? Okay, I think it's not so, because this SR is quite confirmed already, this value. Then SR divided by 3, then this formula 3 VI conjugate. So I will do so quite common. So the answer should not be run away too much from this. Yeah. Or if rectangular format, then possible lah. If you change it to rectangular, it's 800, then it's correct. Okay. So our format problem, you consider same answer. Okay, so if no problem, then we go to chapter 6. So I asked you all to watch the recorded video for chapter 6, right? Then now I'm going to do the briefing for chapter 6. Oh, chapter 6 is easy busy. Easy busy is a word that my son teach me. Then no, easy busy. Okay. Symmetrical faults. Okay, so after symmetrical fault, we have unsymmetrical fault, then protection and economy dispatch. The last 2 chapters are economy and protection. Actually, one session can settle. 1 week can settle both chapters already. So means we only left, I think, 3 weeks like that. Then we can settle all. Then we can go to the revision. Past year question, and also your test. Okay, short circuit. Have you all watched the recorded video? Of course, no. Going okay. So basically, symmetrical faults. It means here. Okay, you have line A, line B, and line C, right? Phase A, phase B, and phase C, 3 lines. Then if all of them short together, we call this symmetrical faults. Can you understand? Very easy, right? So means if symmetrical faults means you are going to have the same values for all. Okay, all 3 of phase short together. Unsymmetrical fault means the system is no longer balanced, very common but less severe. Because why? Why very common? Because unsymmetrical fault means you only maybe phase A and B short only, or phase C short to ground only, or B and C and B short only. So means this is unsymmetrical fault. Okay. So in the industry, right, mostly people will consider calculations for only symmetrical faults. Unsymmetrical fault, normally people won't care about the calculation. Can you tell me why? Yes, because symmetrical is more severe. So, although it's very rare, but then if you consider for the serious case, you can protect for serious case. Of course, the not so serious case will under protection as well. So they do the protections design right only for symmetrical faults. Okay, so this is why industry people only consider symmetrical fault. Okay, the causes of the faults, I think you can go through lah. So why you need to learn fault analysis? Because you need to determine the maximum currents that to ensure the device can survive the fault. So you need to know the maximum current that the device can support. Then also determine the maximum current the circuit breaker need to interrupt and correctly size the circuit breaker. Circuit breaker also can be very expensive, yeah. So if you buy the wrong size, and you cause the whole bill very expensive, then your client will ask you why buy the so expensive circuit breaker. Then you might have problem. Okay, all things related to money, then we'll have problem. Okay, so if you then you need to that's why you need to determine the correct size. So how you determine correct size? Then you need to know fault analysis. You need to do the calculations and see, oh, this is a maximum fault current that it will flow through. Then okay, what is my circuit breaker size in order to stop the trip the current? Okay, circuit. Okay, so this is symmetrical fault. Limitation of fault current. So short circuit current is limited by the impedance of the system. So impedance diagram is important because in order to calculate the short circuit current, you need to know the impedance diagram up to the point of the fault. So if your fault here, right, you need to calculate generator and transformers impedance. Yeah, fault occur at point F, then short circuit from generating and we have a value limited by the impedance by generator and transformer and the line. Generator, transformer, and the line. Okay. So it's an assumption bit. So this will be the formula. We learned about PU, right? And now you have another something like PU, but they call percentage reactance. Okay, it's a total phase voltage drop in the circuits when the full load current is flowing. So it's basically percent X equals to IX, full load current multiplied by the reactance in ohms per phase, divided by the phase voltage times 100. And then, this is a percent X if given in kVA and kV power 2. Then the short circuit current will be the V or divided by X or the full load current. Full load current multiplied by 100 divided by the percent X. So if the percent X of an is 20% and the full load percent X of an element is 20%, you can treat it like a impedance value. Just that last time impedance value in ohms, right? Then your impedance value in PU, right? And now the impedance value in percent, like that only. Okay, it's another way to represent the impedance. Okay, so if 50 amp full load current, then the short circuit current will be 50 times 100 divided by 20, so it will be 250. For a full load 50 amp at full load, means you on all your load, so it means full load. The current is only 50 amp, so the short circuit current will be 250 amp. It will be much larger than the normal current. Can you understand this? Okay, then the percentage reactance at the base of kVA. So again, you have a base value, something like your PU. Base kVA divided by the rated kVA times the percentage reactance. This one, for example, a 1000 kVA transformer, right, with 5% of reactance. So this is one a 1000 kVA, right, with 5% reactance. Okay, we'll have a reactance of, so it's going to, if it is 22, so if the base value change it to 2000, that means this one will change it to 5 will become 10%. Okay, so it's a bit like the PU thing. To change a new reference, and you have to adjust according to the value according to the new reference. Okay, are you okay? We break for 5 minutes. Okay? Hi, can we continue? So it's exactly 5 minutes break, right? Okay. So Nicholas asks, how come when we increase the base, the person increase also? Yeah. Huh? Uh, it's different story, yeah, Nicholas. It's different story. This one is actually more a ratio type of question. Ratio 1000 kVA it is represent it is having 5%. Then if it is having 2000 kVA, then it should be 10%. Understand? So it is actually the ratio questions only. You get what I mean? Like something like two 2/1. Then if you want to have over 4, then this one will be 8. So every actually they are the same. So but then you increase the other ratio, that the other parameters, and to maintain the same ratio, then yeah, another parameter will have to increase as well. Okay. So but then the per unit is different. Per unit is what? Per unit is actual divided by the base, right? So if you increase a base, means your PU will decrease. Okay, it's different story. This one is actually, I can say that this one is already the so-called your PU already. Okay, it is not in ohm. This is already in PU, but then it change base, then it change ratio only. Uh, Related to percentage reactance formula. PU is PU, percent reactance is percent reactance. Just that I want to tell you that but the concept wise is the same. Means you have ohm, right? Then you don't want ohm, then you change it to PU. Then now you change it to percent, like that only. Okay. Ah. Okay, we look at example. Consider a three-phase transmission line operating at 66 kV here and connect through a 1000 kVA. Important. This kind of percentage things, short circuits, important in your in your midterm test. Your midterm test until lecture 6. This chapter. Am I telling you too many things? Okay, you no need to have so many info, right? Yeah. Cannot. Later you say I give you too many tips. It's not. It is unethical. Yeah, 5 star. Yeah, lor, 5 star not easy to achieve it. Okay, must give me 5 stars. Okay. Consider a three-phase transmission line operating at 66 kV. So the line here, 66 kV, okay, and connect through a 1000 kVA transformer. So info is stated as a diagram. 1000 kVA transformer with 5% of reactance to the generating station bus bar. Okay, bus bar. Yeah, if you don't know what is bus bar, you can consider as a cable. The generator is of 2500 kVA and with 10% of reactance. So can you see? Yeah, this one 1000 kVA, this one 2050 kVA. Then definitely they will tell you a base kVA. Suppose a short circuit fault occurred at a high voltage. High voltage means here. Terminals of the transformer means here, not the line on the terminal. Okay. Then calculate the short circuit current. So so the questions they choose 2005 as a common base. So means if 2005 will be the base, it means 10% here remain. But this one 1000 kVA 5%, 2500 kVA, you want to change it to 2500 kVA, then how many percent? Ratio, how many percent? So it should be 5 plus 2, you get 1000 so 2.2 12.5. Yeah, 12.5%. Then this one 10% remain the same. Then you get so means your fault is here. So you need to add up everything, or it can be series or parallel. This one very clear, it is a series, right? So you need to add up until here. So it will be generator and transformer. So generator %x plus transformer %x, will get this. Okay, then you calculate the full load current. Full load current will be the equation is I equals to S over sub 3V. Yeah, S over sub 3V. Then you get this value. Then the short circuit current will be the full load current times 100, fixed already, this 100. Then divided by the %x, 22.7, 22.5%. Then you get 97.2%. It means what? From the full load current, the normal current at 21.87 M, if it is a short circuit current, then it will cost 97.2 M if the fault is occurred at here. Okay. Can you get it? Any question? So the solution, now they choose 5,000 kVA. Why 5,000 kVA? Nothing like, actually. They just change the ratio from 2005 now to 5,000. So actually you will still get the same answer. Or you change the ratio base value, that means the ratio here will change off. %x for transformer and generator will be changed out. Total will be changed off. So yeah, you are going to use a different S value. Yeah, the step is the same, just that you are going to have whatever value of the base kVA, the short circuit current is the same. Okay. Then after short circuit current, we also can calculate another theory part will be short circuit kVA. Okay, short circuit kVA means short circuit power. So the formula will be this: base kVA times 100 divided by %x. Okay. So nothing lah. The steps is whatever I teach you means the steps. So we can look at this question. So this one again, the A, you have 15,000 kVA, 30%, 20,000 kVA and 50%, 12,000 volt, and then here we have the single line. Okay, so they change it to the reactance diagram. Change to the reactance, that is basically something like this. Okay, so the fault will occur at here, right? Means the fault is here. Okay. Then solution, nothing. You find %x, %x a xp to the new new reference value 35,000 K. Okay, then the full load current S over sub 3V. Okay, then why you need to do parallel? Because according to the circuit, the fault is here. So this line and this line is parallel. So not every time plus together. So %x here is parallel. So you do parallel. But then it will be only parallel or series parallel only. It won't be any other method, connection method beside from parallel series or series parallel. Okay. Then you get the short circuit current formula like that only. Then another questions will be example over here. One of the F1 fault will be here, another fault will be here. So if the fault here means you need to cut this one plus this one only. If the fault here means all plus together. Okay. So you see if the fault at F1, then you do this one is a bit special. You need to use this formula. Why you need to use this reactance in ohms formula? Because this one they give you %, right? This one give you %, but then this is 1 ohm. You see 4 ohm. So if it is even in ohms, then you need to use this formula. KVA means the S value. The S value in KVA. So means you know where is the S value. Now 10,000 KVA. So means you substitute 10,000 in already. 10,000 in. Understand? You don't need to substitute 10,000 times 10 to the power of 3. No need. Okay. So if it is MVA, then you need to change it to KVA. Then only you can substitute value here. Okay. Then reactance in ohms over 10 times kV value. So kV value, can you get what I mean? You need to see properly can look properly the symbol kV. The K, can you see? 10 kV. So you don't substitute 10 times 10 to the power 3 V. You don't substitute V, you substitute kV value in. Understand? So you substitute 10 can already. Then you get 40%. So this is to convert the ohm to percent. Okay. Then same thing, same formula you apply from here. So one will be inductance, right? One will be this inductance, one will be for resistance. Okay. So if you have resistance and R and X, so you cannot plus together so easily. You need to all the X plus together, all the R plus together, then use this one. Square root R squared plus X squared. Then you get the answer. The total impedance. Okay. Can you get what I mean? Then to find the short circuit KVA, nothing lah. Just use the formula just now only. This one. Base KVA times 100 divided by percent X. Base KVA given 100 fixed already. So percent X means the total. You are counting, I think this question one is F2 point here. So means all plus power 2, then plus with this one power 2, then square root it in order to get the total impedance. Okay. Then you substitute in here 10,000 base times 100 divided by this percent X value. Okay, so if the fault happened occur at F1 here, so only need these two. Right now, XA and T transformer. Then circuit breaker selections and field selection, just a theory. At the end, how do we know if 12 kV is a phase voltage or line-to-line voltage? This is a good question. When the line or phase voltage is not given, I can tell you, you just use whatever value that they give you. I believe it should be line voltage. I believe it will be line, because normally we won't, if not stated right, then normally it will be line voltage. Still remember, tell you, line to line voltage is more important. Okay, because this is a box, this is a box. Understand? Okay, but then in this chapter, line voltage or phase voltage is not really a very important thing, because when you change it to this kind of we call it per phase analysis or impedance diagram type, right? Okay, so it's actually, we won't really care about the line or phase voltage. Okay, we look at this one, where is it just now? 10K or 10K transmission line. So we will know that this whole thing will be actually the 10K line, 10 kV line. 10 kV line, but of course transformer here, before transformer should be different it should be set out down according to the transformer ratio. Okay, page 14. Page 14, we use phase voltage, normal phase voltage in volt. This word normal phase voltage in volt. Phase voltage in volt. Phase voltage in the phase. My point of view will be, it is actually, I don't really care about this phase or line voltage. Is it because to me, when we talk about 10K line, it means the whole line here 10K lah. So it doesn't matter it's a phase or line voltage, and I will use that 10K to do the calculation. Okay. Yeah, but then since you raise up this questions that nobody raised up before, I will try my best to look into it. Okay, and then I will make I mean, if I have any conclusion, I let you know. Okay? But so far, actually nothing like, because so far is actually whatever value they give you, then you just use. Because once you change it to the impedance diagram, like just like last time your PU, still remember your PU chapter, you already changed the circuits right into the impedance diagram. Like then whatever line, still remember it's set up and down according to the transformer ratio. They give you a base value, then you set up and down according to the transformer ratio, right? Then we won't care about the voltage actually is phase or line voltage. We will just use the voltage and then continue to do in our calculation. This is what I want to tell you. Okay, so if you are okay with this chapter, so this chapter is basically about symmetrical plots and the percent thing. I can say that the main thing will be, okay, the main focus will be, yeah, question 4. Why question 5 missing? Question 4, 6, and 7. 4, 6, and 7. Question 1, no need to do lah. It's actually is a old. It's not really it's not really important at all. It's actually this chapter actually I did a lot. Okay, last time is a totally different formula that is used in question 1. Then I remove. Then I change it to, because in the industry, right, they actually use they actually use this kind of formula. Okay, so it's more relevant to the industry standard. So I changed it to this. I think you focus in last 3 chapter can last 3 questions can read 4, 6, and 7. Okay. Any question? Any question? I can give you 1 hour, okay, to ask me question. If you have question, you're hungry. The question is you are hungry. Okay, I allow you to go to have your tea break. Okay, if you don't have any questions, then I will dismiss here. Okay, I don't want to continue. It's because you all don't have questions. Okay, so okay, no lah, I give you all. After that, then please continue with your tutorial. The last 3 questions. Then you can watch the recorded video for the unsymmetrical fault. I think our class for this week is until today, right? Friday and Friday is replacement class. Is yours or I can't remember. Do I have other class with you all? Try back Tuesday, Wednesday, today only. Okay. So yeah, then next see you all next week, and yeah, do your tutorial questions, and you can watch a recorded video for unsymmetrical force. Okay, the midterm test who is midterm test is in week 10. Week 10. So it's we have more than enough time. I don't want to see you. Okay, and I tell you that actually which chapter? This chapter? Just now, this symmetrical fault chapter. Okay, and what I want to tell you is seriously the COVID cases is quite a lot in our college, in RUC. Okay, so now before that actually still have a lot of lectures, conducted hybrid classes. Now most of them already changed it to fully online. That's why lor. Okay, then 人间 you don't come out, okay, better stay at home. Yeah, but right now the new SOP is actually the close contact, right? Let me start recording first. Start from 1st of March, right? The close contact actually no need to self quarantine already. As long as no symptoms then you go to first day and third day you go for the RTK test then negative, that means you can move around already. So if the symptoms come out after that, and then the guy or the girl already walk around, then jialat. Why scared to do test? Yes, it's actually better self-quarantine. If not, then because normally the symptoms will come out after a few days, then the person who thought, oh, close contact but no symptoms and RTK is negative, oh, then can walk around. Then a lot of people will get affected. And the people affected then say no symptom again, then no need to quarantine again. So I think the cases will be getting more and more. Of course no lah. If you get COVID, you want to attend your final, don't attend. But I think that final most probably will be online. I think most probably will be online. SPM, yeah, SPM also got student kena. Final I don't think can take leave if you perhaps need to, I don't know, need to join the final for next semester, I think. But never mind. We look at how our top management want to do the arrangement for this. Yeah, a lot of actually UC already asked us to prepare for online exam now, actually. So but then not yet officially announced, yeah. So we wait for the official announcement, and I will let you all know. Okay. So don't worry about the final first. Get ready your knowledge first. Okay. Okay. Any other question? So means that what I want to tell you this is, yeah, so temporarily I think I will make it online classes first. Okay, and let it. I mean, let the cases I think reduce, and yeah, perhaps after more stable first, then only we consider physical classes. Maybe end of the semester, I try to arrange maybe 1 to 2 physical classes. Okay. If you don't have any questions, then we will dismiss here. See you. Bye. Take care. 1 meter normally is useless. Okay. um, yeah, actually it depends on luck.